Molweni guys. Sapho lethu maqoma lo. Today we just focus on calculations. We did a bit of theory and at least abantu they have idea of what's going on. So we'll be doing a DC machine calculations. Remember when I'm saying machine in embaneni, I'm meaning it's either ndithetha ngantoni, it's either ndithetha nge-generator or nge-motor, guys. When kansithi DC machine, I'm generalizing, yabo, between a generator and a motor, yeah. But we start with uh, before we start with the calculations, it's important for us to know the types of these DC machines. Okay, so a type of DC machines, there are two categories of DC machine. Mangale up. The first category is self-excited. Okay. With self-excited, guys, is self-excited simply means that uh, umbane uh, umbane we we-amateur nombane kwi-field winding is the same, yabo. For example, if usithetha nge-self-excited generator, the electricity that is being generated by that generator is being supplied to its field winding. Loo nto isithi self-excited. If usithetha ngemoto, the electricity that we are supplying to that motor um, is the one that supplies the armature and the field winding. What do I mean? For example, self-excited, it's subdivided into uh, a series machine. Okay. The naming, guys, in naming of machines comes after the type of connection that is between the armature and the field winding. For example, for us to name, yabo, for us basically here to name the type of machine, we look at the type of connection between the armature and the field winding. If the armature and field winding are connected in series, that is a series machine. Okay, let us draw it. Okay, armature and field winding are connected in series, then we call it a series machine. Okay. Let me go back to why are we calling this self-excited. The reason we are calling this self-excited, suppose this machine is a generator. Okay. Mosi, umbane is being generated at the armature, the spinning, which is the spinning part of the machine, then is taken to the external circuit through brushes. We know that, we see that a current that is being generated by the armature, it's supplying a field winding so that even a magnetic field. So this machine is basically exciting itself. Yabo, ayidingi another supply for us to supply current so that benefit magnetic field around the field winding. Okay, that is why we call it self. That's why we call this category of DC machine self-excited. Yeah, it doesn't need another supply, a separate supply to supply intoni a field winding. Yeah, for example, if let's say this is a let's say sorry, if let's say this is a what? This is a series motor, and it motor must we are supplying, yeah, we are not generating. So a current is up a current because we are supplying a voltage, okay, which is I load. If you can see up and the same supply that is supplying umbane to the to the armature, and this is a motor mos, is the same supply that is also supplying umbane to the field winding. That is why we say self-excited. Okay. Then the second subdivision is self-excited machine. Let me write it as B. You know, a shunt machine. Okay, a shunt machine. Okay, guys, this name shunt means what? Parallel. So it becomes obvious that when we say shunt machine, we mean the term when you give a causal tier a DC machine, you look at the type of connection between the armature and the field winding, of which is if the armature and the field winding are in parallel, we call it a shunt machine. Okay. Okay, this is the field winding. Okay. And we can see, guys, it is a self-excited still because i-field winding ayinayo i-supply sayo esi-separate. Yabo? Ayina-supply sayo esi-separate. If lo mtshini is a generator, i-field winding isaplaywa yintoni? I-current esuka ku-armature. If it is a motor, i-field winding isaplaywa kwangulo mbane oyi-one lo usiwusaplaya to armature. Yabo? Okay. Then the last type of your self-excited machine is intoni? A compound, guys. Compound machines. Okay. We know that a compound means it's something that is combined. Yabo? So a compound machine, it's a combination, yes, series, parallel circuit. Remember, remember we electrical circuit must have two types of circuit, series or parallel. Then the compound circuit is the one where they combine both series and parallel. They combine the combination. Okay. Okay. Upper guys, all compound here is subdivided into two. One being short shunt. Okay. Meaning, what does the short shunt mean? I'll just show you now, guys. I'll show you now. Okay. It simply means, a short shunt simply means that a shunt, yeah, sorry. simply means that a shunt field winding, and it is obviously series field winding because this winding is connected this winding is connected in series with the armature. And so lena yintoni series field winding there. So a shunt field winding, let me use this color. A shunt field winding is only shunting, it's only connected in parallel with the armature. Hence the name short shunt. Okay, then we have Gengoku, the second the second type of compound machine indoni, obviously indoni, a long shunt. Yabo. And okay, after what I've just explained, it becomes clear that a shunt field winding is gonna shunt the whole combination. Yeah, bo? It's gonna shunt the whole combination. Okay. Okay. Here's the series now. Yeah, one a long shunt will shunt, sorry, both the series field winding. Yeah, sorry. To shunt both the series field winding and the armature field winding. Okay, the second category. The term was a categories ZTC machines A2. The second category, let me write it in blue, is self-excited. Le is self-excited, there's only one type. And you're sorry guys. The second category is I'm making a mistake. But a second category of DC machine is separately excited. Okay. Just by that definition I gave with self-excited, it simply means this type or this category of DC machine has two supply. Yeah, okay. It has two supply. For example, if field winding supply sayo ine-supply sayo esisodwa. Ana? Okay. Then i-armature ibe ne-supply yayo iyodwa. Meaning which upper we have two separate circuits. Ana? Two separate circuits as supplier with from different sources. For example, if this separately excited machine is a generator, uh, if it is a generator, okay, so konyanzeleka sibe ne-supply yabo to supply i-field winding so that bene-magnetic field. Then ke ngoku le-armature will start to generate umbane, but lo mbane ugenerethwa yi-armature, it's not supplying the field winding as in the case of self-excited. If it is a motor, we are gonna have to have two supply. And supply a field winding, then we supply and only armature. So this type of machine is expensive because in order for us to operate it, we need two supply sources, and which makes it rather expensive. So I say cool. Uh, now that we talked about eight types of DC machine. I want us to go through the formulas, yabo, so that we'll be able to do a calculation. Okay, but again, a formula endizoqala ngayo nansi is EMF equation of DC machines. Okay, guys, listen to this carefully. I'm saying EMF of what? EMF equation of what? DC machines. Meaning, guys, le formula ndizonibhalela yona i-aplya to both intoni. Yeah, ungayisebenzisa kwi-generator, yeah, calculations ze-generator. Ungayisebenzisa nakwi-calculations zemoto. Yabo. That is why I said EMF equation of a DC machine. Andithanga EMF equation of DC generator. Andithanga EMF equation of DC motor. Ndithe machines. That means this equation applies to both a generator and a motor. Okay, and this equation goes as follows. E is equals to 2 wave-flux ibe ngu-P, ibe ngu-N, ibe ngu-Z, ibe ngu-60, ibe ngu-C. Okay, now I want to talk about quantities as the equation, and units zayo. Okay, we have E yintoni? EMF. Okay, and we know that EMF is measured in volts. Okay, then lena yintoni? Is flux, and we know that it is measured in Webers, but it is often given, given in milliwebers. Sorry. That is why most of the time you have to use this scientific notation 10 to the power -3, because it's often given in Webers. Often i-value encinci kakhulu, such that it's in milliwebers. So it's often given in milliwebers. Then elandelayo intoni? Ebezi pole pairs. Okay, guys, notice I'm saying pole pair. I-pair into eza kabini. Yabo? I-pair is something that comes twice. Zinto eziyi-two, sorry. If we are pairing, let's say we have in this case it comes twice, we have 12 poles. The total number of poles is 12. That means it pairs up. If we have it pairs as 6, you just take the total number of pole and divide it by 2, then you get it pairs. If I have a 4-pole machine, that means I have two pairs of pole. Yeah, because the reason we sithetha nge-pair, kaloku kumele ube ne-north, kumele ube ne-south. Yabo, yiloo nto ke ngoku i-formula laphi ithetha ngentoni? Nge-pole pair. Then we have i-speed, okay. Then yintoni kanene into emuvayo kwi-DC machine? Into emuvayo kwi-DC machine is the armature. So apha we are referring to the speed at which the armature is rotating, and the speed is measured in revs per minute. Okay, if you are given speed in revs per minute. That means formula yakho izoba nalo 60. But if it is given in revs per second, you can simply remove that 60. Yabo. Then ukwazi ubala inoni i-EMF. Yabo. Or you can first convert those revs per second into revs per minute before you substitute with a formula of 60. I hope you get le nto ndiyithethayo. Then ke ngoku sibe no-Z. U-Z yintoni? Number of amateur conductors. U-Z lo. Number of amateur conductors, that is our Z. Yena? Then ke ngoku u-C yena guys is the type of connection of the armature. There are two types of connection with armature. It's either you're gonna have a lamp or wave connection. Anna? So for a lamp, let me write type of connection okay or in the armature. Okay. Of which is OC is equals to 2 when doing a wave connected armature. Then OC is equals to 2P for a lamp connected armature. Okay, laphi ungilophi yi-1 nalo ubulaphi ungilaphi wentoni we-pole pairs. Okay, now ke ngoku we're gonna start to talk about, we're gonna start to be more specific now. Yeah, but what do I mean? We're gonna start to differentiate ke ngoku ii-formulas ze-generator neze-motor, because until le i-formula yona i-apply to both intoni i-generator and motor. Has that into is that we kwi-generator intoni i-generated EMF. Okay, if sithetha ngo-E kwimoto sithetha ngantoni? Sithetha nge-back EMF. Okay, i-back EMF guys ngumbane that is being generated kwimoto. Okay, one would ask, hayi bo, imoto iyawugenerate umbane? Yes guys, imoto does generate electricity, but the electricity that it is generating, it is opposing lo mbane that we are supplying. Hence we say back EMF. It is reacting in a way, yabo. That is according to Lorenz's law. I don't want to get into too much theory ke namhlanje, yabo. But imoto does act as a generator once it starts spinning, but its electricity is opposing the electricity that we are supplying. Yabo. Hence, once imoto starts to run, ayisayidingi start, yabo, because i-back EMF is iluncedo kakhulu. It enables the motor to regulate or control i-current, ingabi too much, yabo. Imoto idinga istarter because xa i-amateur imile, i-back EMF ngu-0. And i-back EMF yile icontrol i-current. Yabo. We have to use a starter and get the motor to a running speed so that i-back EMF starts regulating intoni a current. Yabo. I'll make another session for loo nto leyo. So the first person endifuna siqale sithethe ngayo apha yintoni? i-generator. Okay, i-DC generator. Okay, okay. The first equation ye-DC generator that I'm gonna mention is the EMF equation ye-DC generator. Guys, you see now I'm saying it's an EMF equation of a DC generator. I don't want to see a situation whereby you're using this equation kwimoto. Yeah, but no, this equation only applies to indoni a generator, a DC generator, which is E is equals to B minus B plus IA RA. Okay, where E is indoni, E is a generated EMF. Then UV, ne? UV is the terminal, or abanye ke bathi it's a terminal or indoni a load voltage. Voltage. Okay, then IA indoni armature current. Sorry, IA indoni armature current. Okay, then R A indoni armature resistance. Okay, so guys, yabona ke le equation only isebenza kwintoni kwi-generator only, but xa ndifuna i-equation endizoyisebenzisa in both generators and motor, we use this one, yabo. But ke ngoku kulena mele uqaphele something. Kulena le EMF that applies to both machine in quantities that are not electrical. For example, what am I talking about? If flux ayikho electrical, it's magnetic, it's a magnetic quantity. I-pole ayikho electrical. I-speed asikho electrical, it's mechanical quantity. Even the number of conductors, the type of connection, those are non-electrical values. Yeah, but this equation is derived based on a construction of the machine. Hence, it applies to both generator and motor. Yeah, but the one that I've just written for you now, iyabona uba apha we deal on this equation deals only with electrical values, which is the voltage, the current, the resistance, the EMF. Yabo? Okay. So you must be able ke ngoku guys, sithetha nge-generator apha, ne? You must be able, the only calculations esizodila ngazo apha kwa-N3 ziyi-two, zii-calculation ze-series neze-shunt qha, yabo. So what do I mean? Let's say ndithetha ngantoni? Nge-series DC generator. Thetha nge-series DC generator. Okay, please guys, jonge kakuhle apha, ne? Please be careful. I want you to take note of something. Okay. Xa ndithetha nge-generator, i-current, i-source current, xa ndithetha nge-generator, i-current isuka phi? Isuka from the armature. because umbane ugenerateka kwi-armature then uye kwi-load. I-load nantsi apha kwi-terminals, mhlawumbi ndingakonektha isibane yabo. Okay, so i-armature, then let's say ke ngoku remember is-series generator is a self-excited generator as I've just defined ngoku bendiqala le session. Then I bani ngu-I series ibe ngubani ibe ngu-I load. Remember ke ngoku guys, we said it is a series circuit. What do we know about a series circuit? We know that the current is the same. Yabo, ngamanye amazwi u-IA is equals to I load is equals to I series. Andifuni ke ngoku xa i-question ikunika ikuxelela uba the load current of a series generator ube uscratch intloko uba sizoyifumana njani amateur current. It's right there in front of you. I-amateur current is equals to i-series current is equals to a load current because this is a series machine. Okay guys, coming to enye ke ngoku i-type of DC generator esizokwenza i-calculation ngayo yintoni? I-shunt DC generator. Okay, shunt DC generator. Okay, let us write it down. Nancy, no? Okay, it's a parallel circuit almost, no? Okay. Dite every time every time kawuzothila nge-generator, i-source current yakho isuka phi? Kwi-armature. So i-source current yintoni? Armature current. Then according to Kirchhoff's law ke i-current iyasplita kule junction. Ibe ngu-I shunt lona ibe ngubani? Ngu-I bani? Ngu-I load. Okay. So if I have to remember EMF equation ye-generator ithi na V plus IA RAC. If I have to find IA and NI, I would simply just say IA kwi-shunt. This is kwi-shunt, because the current kwi-shunt is not the same. I would say I is equals to I shunt plus I load. Yabo. And there is another formula ka-Ohm's law that we can use to calculate intoni? I-shunt current. Remember, kwi-parallel circuit i-voltage is the same, meaning i-terminal voltage, i-terminal voltage elapha is the same as the voltage across P, is the same as the voltage across intoni? I-shunt. So we can use Ohm's law and say, oh, I shunt, if we are not given, we can calculate it as V over R shunt. That is Ohm's law. And guys, it is wrong to never use this formula and say, well, I'm amateur. We should again, I amateur is what? V over R amateur. This formula doesn't apply. Yeah, but this formula doesn't apply, partly because kunento ezinjenge-back EMF, yabo. The correct formula would be to say the correct formula for a formula enje, it's B minus E RA. Okay, of which is E ungangabi nayo, yabo. That is the only correct formula. Okay, this one never apply this, please. Okay, I think sigqibile nge-generators. Let us look at kwimoto. Mandiqale ndithi EMF equation of DC motor, okay, of which is its E is equals to V. Instead of saying plus, you say minus IA RA minus. Yabo. So this EMF equation, it's specifically for intoni? Motor. It is the motor. Specifically for intoni? It is a motor, of which is E, we know kwimoto. E kwimoto intoni? I-back EMF. Then V intoni? Is supply voltage. Remember kaloku imoto uyisaplaya ngombane, ane, kuze isinike intoni? I-mechanical power. And the input is electrical, the output is mechanical. Hence ndisithi loo V akafani nalo we-generator. U-V kwi-generator i-terminal voltage or load voltage. Lo u-V kwimoto intoni? I-supply voltage. Please be aware of ezinto ezinjalo. V is equals to the supply voltage. Okay. Then I say intoni? Armature current. Okay. Then RA is saying intoni? Armature. Sorry. Armature resistance. Armature resistance. Anna. Okay. Then ke ngoku let us look at a series DC motor. Okay, let us draw series field winding, then we armature. Okay, guys, the difference is that motor is source current isuka from the supply. Remember kwi-generator is source current isuka phi? Kwi-armature, because we are generating umbane. Yabo, apha we are supplying, we are not generating. So we are supplying electricity. This is our supply. Yabo, mhlambi a low power supply or mhlambi low battery, whatever is supplying the motor. Yabo, notice the direction of current isuka phi? Isuka from apha being I load, then ihambe I series, ihambe nalapha. Yabo. But because this is a series circuit, I load is equals to I series is equals to I armature, because we know that in a series circuit the current is the same. Uyabona Kirchhoff's law no Ohm's law basa apply. Yabo. We don't have to be talking about resistors qha kuze apply Ohm's law. Apply nalapha. Those are laws, guys. Yabo. Those are facts. They are laws of nature. They don't change. Yabo. Then let us go ke ngoku kwintoni? Kwi-shunt. Sorry, shunt DC motor. Okay, sorry, shunt DC motor. We know that if field winding is connected in parallel, shunt field winding is connected in parallel with the armature. Okay, okay. I want us to look at the difference between upper and you'll see the real difference but between calculations generator nezemoto. Yabo, andithi uyasaplaya guys apha umbane ne. I-source current isuka ku-I load ayisasuki ku-I armature as kwintoni kwi-generator. Yabo, hence ke i-source current izosplita apha ke ngoku as I load ibe ngu-I shunt then ibe ngubani? Ibe ngu-I armature. Okay, meaning which I load is equals to I shunt plus I armature. We are just applying Kirchhoff's laws. Yabo. Okay, we are looking at by current flow kanjani kwimoto and or if it's a generator, we're looking at by current flow kanjani kwi-generator. But i-current ezoyidinga according to the formula, i-current endizoyidinga kakhulu kwi-calculations zam ngu-I armature. Hence ke ngoku, if I take this formula and make I armature subject of the formula, I find that I armature is equals to I load minus I shunt. Yabo, ngifuna ke ngoku notice i-difference. Andithi this is a motor, but sinyuke ngosiye phaa kule generator. Yabo, yabo I armature we-generator unjani? Uyazi-adda. Yabo, but I armature wemoto it is different. Yabo, I want you guys to apply understanding. Because if you apply understanding, you won't make silly mistakes. And another formula for a I shunt still stands ubani go V over R shunt. Never say for a armature V is equals to V over RA. This is wrong. And the correct way is to say IA is equals to V minus E. But ke ngoku izokunika i-challenge le formula because sube ungayazi ntoni i-back EMF. Okay, now that I've shown calculations the EMFs for both generator and and motors, I want us to just quickly go through into a power. Because guys, the reason why I want to go through into a power is because abantu they like making silly mistakes. Silly mistakes when benikwe ipower kwaphinde kwakhutshwa i-efficiency. Baba confused. Guys, in this subject, yabo, the power that is always given, power that is always given, if you are given a power, what were kilowatts, don't kilowatts, yabo. Given power, it's always in what? The output power. If bakunike power and they don't say anything about that power, they just write it by okay, power don't kilowatts or battery and a 5 kilowatt motor. That power, its output power, doesn't change. Whether noba battery a 5 kilowatt generator, that is output power. Unless they specifically tell you about the input power to a generator or the input power to a motor, then you can take it as input because now they are giving you a directive but the power lesignify on the input power. But if they are not telling you by which power it is, you always take a given power as in only the output power. Okay. And another thing ke ngoku ndifuna uyicacisa with regards to power. Guys, kwi-generator, ndiqala apha kwi-generator. I-input power kwi-generator injani? Sorry, input ndifuna uthi input power i-mechanical. And we spin the turbine, or we spin the armature, then we generate electricity. So the input power is what? Mechanical. Please guys, ndingaze ndinibone like I don't, ndingabona umntu ethi kuthiwa calculate the input power ye-generator esebenzisa le formula. P in is equals to V times V times I load. This is wrong. Yabo? Kwi-generator, this formula, le formula of V times I ubelonga kwi-output. Yabo? Because i-output yethu itheni? It is electrical. That's the first thing kumele uzibuze yona. Kuba okay, kwi-generator neni input power i-mechanical. So anosebenzisa u-V times I to calculate input power. If ndisebenzisa u-V times I, that means ndicalculate yintoni? I-output power. Yabo? Okay. So yiloo nto ndifuna niyibone. Yabo? And guys, apha this is a electrical subject. I'm gonna emphasize food. This is an electrical subject. There is no formula to calculate mechanical power in this subject. Yeah, yeah, it's not ikhona yona, but it's not part of the syllabus. Yale subject. Yeah, it's not part of the syllabus yale subject. Yeah, i-power also calculate output power, which is electrical. Then if bona bathi sifuna input, then definitely lo question izokunika i-efficiency. Kunika i-efficiency wena umsebenzi wakho kucalculator intoni? Kucalculator i-output power, then usebenzise laa value ye-efficiency to manipulate and calculate intoni? Input power, because remember efficiency is given by power out over power in. So efficiency is the ratio of the power out to the input power. Okay, then in terms of your motor, now, in terms of your motor, into electrical motor intoni? The output power. Yeah, into electrical motor, sorry, and andiziva kahle. Into electrical motor intoni? Input power. Meaning ndisebenzisa u-V times I, I'm basically calculating the input power. Ana? Okay. Then i-output yona itheni? Output power i-mechanical. In some instances i-power if uyinikiwe awuxelelwanga nto, usually loo nto iba yintoni? Iba yi-output power, yeah, which is nice about imoto, because if I'm given i-power ndixelelwanga nto, that means i-output power and output power i-mechanical, yabo. But ke ngoku if bafuna i-input power kulaa moto, you have two options, you. You have this one where you multiply the supply voltage with the load current, or sorry, the supply current. Yabo, because IL we supply current motor, no? Or we have the second option, if mhlawumbi efficiency, you have the second option of manipulating using efficiency. Okay, guys, as conclusion to this section, I'm only gonna do questions. This question. Kemna, I believe in one thing. I teach a person with understanding. Yabo. I don't have to, once you teach a person with understanding, you don't have to go through every question with them. Yabo. When they are doing it's a question bafundise kuzo with understanding. It's like solving a puzzle now. Yabo. It's like iyakwazi ke ngoku you have a guidance about how am I gonna analyze this and how am I gonna solve this. Okay, so I'll do question yours question 2.3 wonke, then ndinenzele question 3.2. Then you go through a question paper. Every question paper that you encounter, you'll be able to answer. I guarantee you that. But okay, the generated EMF, let us highlight that. That is important information in the armature of a shunt wound generator. But hey, Ndoni, it's a shunt wound. It's important, guys, that you underline what type of machine it is, if you are told. Yabo is Bani 425 volts. At the resistance of the shunt, okay, we're given the resistance of the shunt and armature 200. So resistance ye-shunt ngu-200, ye-armature ngu-0.27 ohms respectively. Then they say calculate the following for an armature current of 46 amps. You know? They want us to calculate the full load terminal voltage of the alternator. Okay, alternator and generator is the same name. Yeah, then number 2, they want us to calculate the electrical power of the generator. So let us write down the givens. Okay, we're given a generated EMF, which is E, is equals to 425 and volts. Okay, and we are told that it's a shunt generator. Okay, shunt is a generator now. Then we're given a resistance shunt, R shunt, which is 200 ohms. Then we are given a resistance armature. Okay. Okay, which is 0.27 ohms. Okay. Then we're given armature current, okay, which is 46 amps. Okay. The first question yethu ifuna intoni? I-full load terminal voltage. Bafuna V. Okay. 2.3.1. Okay. Okay. Now we know that in order, formula esinoyisebenzisa apha ne, formula ye-EMF equation ye-generator ne. Okay, which is E is equals to V. With generator we say plus, yeah. Then with motor we say minus. Take note of those things, please. Plus A-R-A, yeah. Okay. First thing before you start getting coming about, you look at what do I need to get this terminal voltage. I am given intoni u-E, yabo. I am given armature current. I am given a armature resistance. Ngamanye amazwi, guys, they were just trying to confuse you by giving you intoni a shunt field resistance oyidingi, yabo, because i-armature current uyinikiwe directly, yabo. Okay, mangathi they were trying to confuse you because okay, you might need it kwi-following question, yabo. Singatsho njalo ne. But if we draw the circuit, nansi le. Okay. Okay. we are given a supply voltage esingu 425. You're sorry, not we are not supply voltage lesifunayo V ku-V, sorry. We are given EMF engubani 425. EMF is generated at the armature. Then we are given intoni armature current. Okay, which makes this problem very simple. It's a matter of substituting and finding OV. So 425 is equals to V plus I armature 46, then resistance armature ngubani ku 0.27, meaning which UV is equals to 425 minus, okay, then let me take my calculator and punch answer ka V. Therefore UV, okay, sorry, 0.27. UV is 412.58 volts. Anna? Okay. Now we have to find ke ngoku intoni 2.3 point 2. Bafuna ntoni? Bafuna intoni? Electrical power output. Yeah. Yeah. The nice thing about this one, they are telling you that the power is electrical, meaning okay, meaning that if power out is given by UV times IL. Yeah, cool. So okay, guys, in this situation, I'm gonna need ubani OIL. Yeah, okay. Okay, that there is a reason. Okay, now we start to see that why they were giving us that shunt field resistance. Scenario E, armature current engu 46 amps. We can calculate I shunt. I shunt is given by a terminal voltage le UV over R shunt, which is 412.58 over 200. So man I shunt it. Okay. I shunt it 2 over 200 is along 2,06 amps, meaning which I load. Remember, if you're gonna use Kirchhoff's law, remember it's called source current. It's source current means IA, so IA is equals to I load I armature is source current because this is a generator. If it was a motor, guys, it was gonna be a different story. Yeah, well, please. Hence, I'm saying when you are dealing with equation, look at the type of machine. Are they talking of a generator? Are they talking of a motor? Or if it's a motor, what type of motor? If it's a generator, what type of generator? Okay, please. Then I shunt. Then that means I load is equals to I armature minus I shunt. Okay, which is I armature of 46 minus Sando Ibala I shunt. then I load would be 46 minus 2,06, which is I load go 43,94 amps. Okay, current that is flowing to the load. Okay, now I have EV, I have I load. Now I can calculate the power out using this formula, V times IL. OV times IL belong to output because output generator, it is electrical. Okay, if ebefune input apha mhlawumbe bendinike ne-efficiency, then nabenzoba le output ndibe ne-output ndibe ne-efficiency, then manipulate to get input, because in this subject we don't have the formula for mechanical power. Please ibe engraved in your mind loo nto leyo, please. So uV wethu ngu-412, 58, then current yangu 43,94. Sibale ke ngoku le electrical power output. Okay. 58 times 43,94. So i-power output yethu izoba ngu-18,12 let's say 113 if nirounda kwi-2 decimal kilowatts. Okay, then masijonge the next question. Okay, the next question ithetha, okay, which is 3.2 ngoku, a 240 volts, so 240 volts, 4 pole. Yabona guys, immediately they start to talk about a pole, a lamp, or yabo, this formula that applies to both generator. I'm going up, sorry. This formula, that's the first formula that should come into your mind. This formula. Yabo, because kaloku immediately ndizoqala uthetha nge-non-electrical values. Nantsi formula esinayo any non-electrical values yile. Yabo. Okay, going back to that question. Sorry. DC. So it's a DC series motor. It's important to note what type. It's a motor. It's a motor, this one. Has a lamp, that is important information because it's telling about the type of connection, armature. Then it has a lamp armature with 880 conductors. But the armature and series field resistance, we are given armature resistance equals 0,13 ohms. Then yes, armature resistance equals 0,13 ohms. Then series field resistance equals 0,24 ohms. Apha guys ke ngoku bona bafuna bona bathi calculate the useful flux per pole if the motor runs at this speed. Okay, it's in revs per minute, which is a good thing, while taking a current of 28,5 amps from the supply. So we are given a supply current. Okay. So sorry kancinci. So Okay, so guys, sorry. Okay, just erasing. Uh, so guys, let us first write a given zethu ne. We are given a supply voltage kule motor 240 ne. Then we are told it's a 4-pole, meaning i-pole pair ngubani? Ku-2. And it's a series motor. Okay, casity motor, we know that a current originator from the supply, and casity series, we know that a current that should tell us that the current is the same. Okay, then bathi a lamp connected, meaning that means OC is equals to 2 times a pole pair, naye ngu-2, which is 4. And then we are given a number of armature conductors, Z lower, which is 880 conductors. Then we are given a resistance armature, which is 0.13. Then a resistance, yes, series field winding, angle 0.24 ohms. Okay, bana basifuna i-useful flux, bafuna i-flux le number se-flux yiyo le bayifunayo. And if the motor runs at, so basinikile n nangu, okay, rev per minute, okay, then taking a current of, so I load lower ne, I load yabo 28,5. I load ke apha guys equals to armature current. I have shown you that but a current in a series machine is the same. Yabo. So you don't have where uzikrwempa intloko ukhangela uba ndizothi armature current ngubani. Yabo. Series, this is a series motor. I load nansi. Nanku la 28,5 amps lo uzohamba apha aphinde azohamba apha aphinde azohamba apha. Yabo. So thina we know that i-formula enale unknown ifunwayo is ilena, ile EMF of machine that applies to both. Ana 2 ana P N Z 60 C. If siyabona apha ne, I have this value, I have this value, I have this value, but I don't have one or E. What other option of calculating for E is using the EMF equation and yemoto. EMF equation yemoto, it E is equals to bani V minus IA RA. Okay. So OV wethu bani 240 minus IA wethu stay, since this is a series. Yeah, this is a series DC generator. Equals to armature current, of which is if it was a shunt motor, if it was a shunt motor, then that would be a different case. That means I would have to first calculate the armature current. Okay, so 228,5, then we are given Masidoni. Okay, we are given a resistance much. But now guys, how dealing a series, I forgot to explain this. How dealing a series, if you are born, if field winding ne-armature are in the same circuit, yabo. So meaning xa ndifaka i-value apha kumele ndizifake zoyi-two, yabo. Kumele ndizi-ede zoyi-two because kaloku yintoni, yi-armature le circuit lena, le field winding since ikwi-circuit eyi-one ne-armature in series, it's adding to la resistance. So le resistance ye-armature nale resistance ye-field winding kumele ndizi-ede in this case because they are connected in series with each other. Yabo, they are in the same circuit. Yabo. Okay. So I'm gonna say 0,13 plus 0,24. Then fumano E1, back EMF. Okay, minus okay, back EMF yam ngu 2,455 volts. Now I've calculated the back EMF. Into emele ndiyenze ngoku is to substitute sorry, ndilibele OC apha kule formula. See here. To substitute and find to manipulate and find flux. So can manipulate la formula, I would see that flux is 60 C over 2P and Z. So of which is E nimbalile ngo 229,45 times 60 times C ngubani ngo-4 then ibe ngu-2 times 2 pole pair ngu-2 times speed nasiya, then ibe amateur conductors. Then now we can say okay, okay. Okay, I'm just punching it in the calculator. So the answer it's equals to 14,9 milliwebers. Okay, guys, we're done for today. Yabo. Guys, ke mna andifuna undiphatha shem, the content endiyipostayo ndixhomekeke kuni, yabo. I'm just trying to help, yabo, people abadinga uncedo, yabo. I'm a tutor by profession. Ndiyatutorisha nale college bendifunda kuyo, yabo. So I'm an expert kwi-electrotechnics, electrical trade theory, i-science, ne-mathematics, ne-industrial. So what I post in this channel is entirely up to what you guys want, yabo. If you can communicate and say, hey Maqoma, sicela i-video on this section, mhlawumbi ye-industrial or kuloo topic we-industrial, I can do that for you guys. Then create a content, yabo. If you subscribe and like my channel, yabo, so that and help me grow this channel because I want to into passionate ngayo le. I want to assist people bapase through excellence. Thank you.